All right, hey there, fellow coder. Welcome to this next lesson in our series where we're building a real-world web app from scratch using Spring Boot on the back end and React on the front end, tying it all together with a MySQL database. So in this one, we're finally getting into the deployment part of this entire conversation. So if you are someone who is curious about sort of DevOps and how to, deploy apps to the interwebs and get off of localhost, this part one of many will be very much of interest to you. So if you want to learn more about it, then stick around. All right, so getting into this with a bit more background, obviously we now have a very basic working version of our application. This is what the industry refers to as an MVP, a minimum viable product. It's not something that I am proud to display into the open internet. I'm embarrassed by it because it's not at all feature rich and it's a little bit ugly, but hey, that is what we have right now. But the point of it is I want to get this out the door and ship it so that my students can actually start using this app sooner rather than later. So how do we do this? How do we actually publish something onto the internet, get it away from localhost and put it onto an actual domain where you can go to like some domain name like assignments.coderscampus.com and see this application in use? Well, there are probably several hundred different options for you, ways to deploy things and whatnot. But basically, I'm going to be leveraging something that's, I don't want to say very common, but from my research, again, the time between the last video that was published, I say old, the time between the last video that was published and this one has been about 2 weeks in terms of my time of me going through and learning all this stuff. So in my learning about this stuff, again, I'm not a DevOps engineer. I'm not, I'm a coder, right? I dabble with some DevOps stuff, but from what I've seen, this approach is somewhat common, where we publish to something called DigitalOcean, but it could also be AWS. I know AWS is popular, or it could be Google Cloud. Like I said, several hundred different options for you. DigitalOcean I chose because it's fairly inexpensive from what I'm seeing, and it was very easy in terms of getting set up. Okay, compared to AWS, AWS has a bit more bloat and it's cool, but there's a lot more going on and a lot more nuances, whereas DigitalOcean just seems to be a, one-click go type solution, which I liked. And with that, once we have a server up and running with through DigitalOcean, let's call it a virtual machine or whatever, we can then Dockerize our application. If you've never used Docker before, then this will be a fun series for you, or mini-series. If you have used Docker, then this is just going to be a review, and you might even have some corrections to the way I do things, because like I said, I'm not an expert with Docker. I've been using it for about 2 weeks, so take that with a grain of salt. So we'll be Dockerizing our front end and our back end for our applications, and we'll be using Docker Compose to bring it all together. And then we'll deploy those containers onto our DigitalOcean droplet. A droplet is just another name for a virtual machine, a little box. It's someone else's computer, right? It's just someone else's computer that lives somewhere where it has a lot of good uptime, so it won't ever go down, right? That's what they call a droplet here. In AWS, it's like an EC2 instance. In, I'm sure, Google Cloud, they have something else for it. But that's the gist of what we are going to do. So let's put on our big boy and big girl boots and see the madness that is about to ensue with this journey. So let's bring up our code, although we don't really need I don't think we need this right now. I'll sort of maximize this guy. So our code needs to be Dockerized. Now, I've already gone through this twice. So I've gone through this entire process twice to make sure that I understand at a high level all the different steps that are needed. But you'll have to bear with me if stuff goes wrong. It's bound to go wrong, just like in my coding stuff. These are not going to be polished videos. So the first thing that we need to do, I should mention, actually, the first thing that I need to mention is I've split apart the structure of our application. Previously, let me just start up a little comment thing here. Previously, our structure was we had the assignment submission app as the root folder. And then within this folder, I believe I had, or how did I have this? I had the essentially the app itself. This was like all of the project structure for our Java codes. We'd have our source, main Java here. We would have our source main test, blah, blah, blah. And then as another folder, we had front end. So our front end code was contained within our back end code, right? So in other words, everything was contained within, directly nested within one folder here. And that is not exactly the suggested structure from what I learned in the last 2 weeks of doing this. The better structure is to split apart your app, your front end and your back end, into separate folders. So you can have a back end, which would then within that have the source, main, Java, etc., etc. And then you'd have your front end code, which is the code that we're looking at here, which has the source / whatever, services, because we have a services. So basically this source folder here is contained within a front end folder, which is contained within the assignment submission app root folder. Okay, and this is important to do because of Docker and the way Docker does things. Because what we're going to do is to Dockerize things within the backend folder. We are going to have a Docker file that talks to, or that tells Docker how to assemble and package all of our back-end application, all of our Java code. Same for our front end. We're going to have a Docker file in here in our front end that tells Docker how to package it all together. And on the root folder, however I want to convey that, I guess it's here. On the root folder, we will have, I guess these are folders. This is a file, folder. Yeah, and then this is a file called dockercompose.yaml. If you don't know what YAML is, we'll talk about that. But that's sort of how things go together. So we have a Docker file for how do you put together the front end. We have a Docker file for how do you put together and containerize the back end. And then how do you put together all those containers and deploy them all as one. Okay, so that's sort of the high level of how Docker wants to structure things. So, and I'm going to go fast here with Docker. Again, this is not going to be a comprehensive series by any means. Basically, what Docker allows us to do is it allows us to package up our application into something called a container, and this container is essentially it's you could think of it as like a virtual machine. It's like a computer all on its own. It's not. There's that's a level of abstraction. It's just think of it like a little computer. So if you're just running this one backend application on this one computer, you can contain it into this one little box, this one container, and run it all within this one computer in its own environment. Do the same thing for the front end. Get it running on its own computer in its own whatever, its own virtual machine. Again, it's not a virtual machine, but they call them containers. So then you have two individual containers that contain the apps, and then these two containers will exist on the same virtual network. So they'll be on the same network where they can communicate with each other. So just like we have localhost 3000 that talks to localhost 8080, okay, that's currently what we have now. We just have it in Visual Studio Code, and then we have it in Eclipse via localhost. That's sort of the same thing. Container 1, container 2, and then they're all in a similar virtual network because we're going to compose them together on the same network so they can communicate with each other. Obviously, that was a very rapid and high-level explanation as to what we're about to do. So, again, this is not meant to be a comprehensive Docker course, but you will see the real-world view of how this stuff gets done. So, to create the first step is to create that Docker file. So we'll create it within the front end folder, which as you can see now, this is called front end. This is our root folder. Everything exists within front end folder. So within this, the same level as the package lock and package JSON, we will create a new file called Docker file. Okay, now my Docker file just turned into a little blue whale there with some containers on it. That was made possible by a plugin that I had to install. So if you're doing this for the first time and you don't have the plugin installed for Docker on your Visual Studio Code, you'll get a pop-up probably in the bottom right that says, hey, this looks like a Docker file. Do you want to, install the Docker plugin? And sure, I would recommend that you do that. Also, you should install Docker. So For my computer, I did it. I have a Windows computer, so I installed Docker for Windows. Now, there's a comprehensive list of steps already on the internet that you can follow to install Docker on your Windows machine. Same for your Mac. If you have a Mac, again, I will not be covering those steps. That might be frustrating for you. I apologize, but there's already going to be tons of content here. So I'm going to assume that you have Docker installed on your computer already. Okay, I realize it's a gigantic assumption, but work with me here. If you have questions about it, if you've run into problems, hey, feel free to comment below. Again, I'm not a Docker expert, but maybe I can point you in the right direction if you're having some trouble. So if you want to pause the video and do that now, go for it. Install Docker, then come back. Go for it. So I'll take a sip of my drink. If you have Docker installed already, then let's move forward. So how does this Docker file work? Well, there's a few keywords that it leverages. Special syntax, if you will. Usually the first line in a Docker file, from what I've seen, starts with a from message. So you are going to be building this application, this Docker container, from an image. So an image is essentially a saved piece of state that represents like the blueprint for a container. So the way I think of it in my brain, and again, this is probably not entirely accurate, but I think of an image. An image is to a container what a Java class is to an object. So the Java class is a blueprint for the object, and the object is the instantiation of the class, right? So you instantiate objects based off of the class blueprint. Same kind of thing with containers. You instantiate containers, you bring containers up into existence based on the image blueprint. Okay, so we're going to be building from an image. The image will be our blueprint. So, having said that, well, what image are we building from? Where are you getting this? Like, what are you talking about, Trevor? So what you can do is, on the beautiful thing called the internet, you can go to the Docker, I think it's Docker Hub. Docker Hub, which is hub.docker.com, contains a whole list of different images that you can search. These images, like I said, are predefined distributions, predefined probably Linux distributions that have software pre-installed on them and are ready to rock for you. So what have we used on our computer to run our React front end? We actually had to install Node. Way back at the beginning of this whole thing, we installed Node.js in order to use NPM, which is a Node package manager, and a bunch of other things. But Node is the sort of driving force of the React app. So what you can do is type in Node. Right? You type in Node and hit enter, and look, oh, cool. Node, the official Node, has official images. So we can click on this guy and see, well, what kind of Node images do we have? Now, there's going to be tons. It's going to be overwhelming, as you can see. So, but the basic thing is there's a version of Node that you want to be using at the front. 17, 16, 14, 12, whatever. So that's the Node version. And is there a way to, if I go to tags, is there another? Yeah, so you can go to tags and filter by, let's say, 17, because I want to use 17 as the Node version. And I think there's one called Alpine. Is that going to find? No, it's not going to find that. What if I just say Alpine? Is that the way to do it? Like I said, I have not properly... Yeah, so it's something like this, right? 16, 14, Alpine. So it looks like I would type in 17-Alpine. It's annoying that I didn't... Can I say 17 asterisk Alpine? No, if I say hyphen Alpine, there we go. Now we get some hits. Come on, guys. I want to use wildcard characters. Anyway, you type in 17 Alpine, and there we go. So what this means is this is a Node 17, so Node version 17, built off of Alpine Linux. And Alpine Linux is a very small version of Linux. Okay, that's why Alpine, from what I've seen in my research, Alpine tends to be preferred because it's a small version of Linux. Other versions of Linux that I've seen are like 300 plus megabytes. So if size is important to you and of your distribution of your containers, then hey, consider Alpine. If there are other considerations you need to make, then by all means you can choose a different distribution of Linux. I'm not a Linux master. By all means, if you have better knowledge in your brain about which image to use, go for it. But I'm going to leverage this one. So basically, the name of the what's this called, image, is here. So after docker pull is the name of the image. I'm going to copy this whole thing. We don't need to use the pull command because we're building this in a Docker file. If I wanted to do this from a shell, like if I had git bash, for instance, I could say docker pull and do this node image, and it would download the image onto my computer so that I can have access to this image on my computer. I don't necessarily need that access to the image on my computer from here. I can build that from within the Docker file. So I can get rid of docker pull, and there we go. So that's the first command in this Docker file. We are going to start from this Node 17 version of Alpine Linux, and from here we can do other stuff, right? So we start from this image. What else do we need to do? Well, we probably need to copy data from our machine onto this container. Because remember, this is a blueprint for how we get the container set up. So we want to copy files from our computer here, right, with the source code. We want to copy it into this instance that we're about to create. So there is a copy command where we can copy files. Now you might want to copy all the files, but that's actually a little bit there's a if you want to copy all the files, you would just say copy like dot and then dot, meaning copy from this local is copy from the host machine is what the language that they use to the I forget, what do they say, host and source? What's the word that they use? Isn't that silly? I can't remember. Let's say container machine. It's not the container machine. You can say from the host to the container, so to speak. So dot, this is relative to the, and I should say paths are relative to the Docker file. So basically dot means where the Docker file is and relative to the Docker file. When you say dot, that means in the same folder as Docker file. And then what this one means is it's at the essentially the folder, essentially the root folder, right? Yeah, it's the root folder of the host machine. No, of the container machine, right? So I guess the first path is relative to the Docker file. Second is essentially relative to root on the container. Come on, Trevor. I can spell. You can do it. I believe in you. Tainer. There we go. So that's where those dot dot. Again, you see this on the internet. You see like copy dot dot, and they assume that you know what that means. But I wanted to give a bit more explanation as to what the heck dot and dot means. So now, having said that, this is not exactly the best approach because you're going to copy all the node modules, and this folder is gigantic. So this is like hundreds and hundreds of files and hundreds of megabytes of stuff that you don't necessarily want to copy over to the container. So instead, what you typically see is you start by copying the package JSON as well as the package lock JSON files. So those two go over to the container. Okay, so we'll start there. We'll copy them over. And then what happens? Well, if you copy the package JSON over as well as the package lock over, and you're sitting with a node machine, a node-enabled container, what can you do on that machine with these two files? Well, you can run an npm install, right? So you want to run npm install. How do you run npm install? You use the run command. You run npm install, and it will literally look at these two files that we just copied over, and it will do an npm install and install all the dependencies. Okay, and then after that, what do you want to do? Well, maybe you want to do an npm build, right? You can build from that as well. Now, the problem with that is you're going to be missing some files. So in between here, we need to copy the rest of the files over. So right now we just have package JSON and lock. We don't have any of the source folders and stuff like that. So now you can say, copy dot dot, sort of. Then you can do a copy. Then you do a run build, and then we'll see what happens there. Let's stick with this. So I've hit you with a lot so far. So now how do we test this? Test this stuff. I would recommend going to like a git bash console if you're on Windows. Otherwise, if you're on just go to a terminal or something on a Mac. I think will work. So you navigate to the directory of your assignment. So my assignment submission app is in the C drive in the Git folder. So this is the root, and then we want to be in the front end folder. So now in the front end folder, which is where the Docker file is, right? So if I list stuff here, we see the Docker file is here. We can now do something with that Docker file that we've now created. You can build the Docker file. So we can say Docker build. Okay. Now when we build, I think we can give it a tag, but I think for now we don't have to. I'm going to keep it simple. So you say Docker build is a command, and then you need to give it the path to the Docker file to build. The path to the Docker file to build is in here. So dot means look in this directory, in the front end directory. Let me see if this works. We'll do Docker build. Seems like it's doing something. Cool. So it's starting to execute our stuff. So let me scroll up. So what you see here is it's loading the Docker file. It's loading some metadata. It's doing some stuff. But now look, from node 17 Alpine. So now our first command is running. So 1 of 5, because we have, I guess, 5 commands. 1, 2, 3, 4, 5. So we have 5 commands here. It's running the first of the 5 commands. So it had to do some initial stuff before it did the first of our commands. Fair enough. And it's running it from, and now there's some stuff here that you see before the node 17, right? We just said from node 17. What happens is this is a shorthand. When you just say from and then you just say the name of the image, it's assuming you mean you want to pull this from Docker Hub, right? Which is why when you go here, it's from docker.io.library. Okay, it's making the assumption that that's what you meant. You can pull images and do images from other images that are not in Docker Hub, right? You just have to explicitly say the path. The URL pointing to that image if you were storing it somewhere else. Anyway, okay, so it's going through, it's doing that first step. Cool. It does some stuff, done. So it took 17 seconds to do that first step. Step 2, copy package JSON and stuff over, done. It did that in half a second. And then npm run install. Okay, so run npm install, which means do an npm install. So it can install based on our package JSON stuff. So it's going to go through and do the npm install. Took 31 seconds. Cool. Now we want to copy the rest of our stuff over to the image. Cool. And then we want to do a build. Oh, shoot. npm run build. Right. I messed up. So cool. Now we see what happens when it fails. So it said failed running at that last step. So the proper command to build is npm run build. I'll save that again and go back. And I will re-execute the same build command. Now, pay attention. This one's going to go a lot faster, I think. It should. It shouldn't have to do any of the other stuff. Everything else has been cached. The steps 1 through 4 should have been cached, I think. Let me hit build and see how fast it goes through. Right? So it's done. The first step is done. Transferring done. 3, 4 is... So it is actually still transferring stuff. There we go. So now it's doing the npm run build, and it's creating an optimized production build. Cool. So hopefully, cross your fingers, the build actually works. And then what that means is we now have brought up from our image that we just created with those 5 lines of code, right? Done. There we go. Exporting to image, exporting layers, done. Fantastic. So we now have an image that we have just built together in 5 lines of code, right? With minimal explaining on my part about what this all means. But we've now built an image. Again, an image is like a class file. It's a blueprint for a container. Nothing's running yet, and we can show that by saying Docker PS is a way to run the list of containers that are, list out the containers that are running. And as you can see, there's nothing running here. It just says container ID. If I say Docker PS-A, it'll show all of the containers, ones that are running and stopped. As you can see, there's nothing. But I think if you say Docker image PS, is that how you list the images? No. How do you list the images again without going, is it Docker images PS? PS-A? No. So I believe, let me go to my Docker. So let me go to Docker for desktop, which is in my tray here. I have Docker for desktop. Let me bring it up and just see if I have an image in here. Yeah, so I have an image in here. Oh, it doesn't have a name, right, because I didn't give it, although it should, something should appear here. My console command knowledge is obviously not as good as it should be. Let me just do a Docker images help. Oh, I just say Docker images -A. There it is. Beauty. Okay. So when you say Docker images -a, we can see we have our image here that we built about a minute ago. It's almost 800 megabytes. Okay. Sweet. Now, it doesn't have a name, so that's actually not great. So the better way to do a build, let's go back to the build command that we had. The better way to do a build is to give it a name, which is -t for tag. So we can call this we'll call this the front end as a tag, and hit enter. So it's going to do another build. It's going to build another image. Okay, it's like another class file that we're building here. And it's going to save it now with a name. Now, as you can see, that was much faster because everything was cached, which is really nice. So now you can say Docker images -a, and now we'll have, well, we still just have the one image because I guess it just re-tagged. It took the existing image that didn't have a tag and gave it a tag. Cool. So now we have one image called front end. And if we wanted to, now we can run that image. We can run, do a Docker run. And I forget the syntax for this. Again, usually I just use this right here. I would just click, run. But there's there's a bunch of things that we can do. So we want to run, and we want to add some ports to it. And let's just add some ports and see what happens. So I think it's -p is to add a port. So if we say Docker run, P for port. So what port does is it exposes ports. For now, I'll just say 3000, 3000. I'll explain that in a minute. And then we need to give the name of the container, of the image, which I think was called front end. Let's try that and see if that brings up. Okay, I didn't see any mess. Let me go to containers here. So we have a container, but it looks like it's not running. So it looks like something bad happened, and I don't know what. Usually we have indicators as to what went wrong. So let me just double check and see. Can I see logs from within there? Log. So log opt, log driver, environment list, CPU, attach. I could be missing something very, very straightforward and very simple. Let me just go to a Docker run example really quickly. Again, as I said at the beginning of this, not an expert. So Docker run options, image, command. You know what? It might have just started and stopped. I think that's what happened. So it actually started successfully, but we don't have a command at the end. So I forgot, I neglected to mention, there's also one more thing here that we would normally do, which keeps the container up and running, which is a CMD, a command at the end. We'll get there though. We'll talk about that in a moment. What I want to show you instead, before we get to the command portion of this, is the fact that we can run this. I believe, is it -i or IT? Is it -i is interactive? Yeah, so let's do a -i. This means that we can interact with the container itself as it's coming up. So let's try -i and P. And I think, do I need to give it another argument? Yeah, because this is not helpful. Can I control C out of here? Oh no, I'm frozen. So let me open up another, let me cancel this and open up another git bash. Users, where is this again? This is in Git assignment submission app, in the front end. So I want to do a Docker run in interactive mode. Port 3, I think the ports don't really matter right now, I don't believe. The name of the image is front. Well, interesting, it doesn't give me an autocomplete. Maybe it's the fact that I'm not giving it the right name. Does it say the image name, or what is image? It doesn't say if it's a name or the ID. Let me do a quick test on Docker. What's the images? So there's an image ID which starts with 1CE. Let me try to do it with this syntax, and instead of calling it front end, I will call it 1CE, because that's the first couple of characters that finds the Docker container or image. So it seems like it's the same behavior. So I believe we need to give it some arguments. So the last part is the arguments list, and this is where you can pass in an argument saying that you want it to run in like shell mode. Do they have an example of like running it in shell mode? Yeah, so here. So you say docker run, ports, name of it, and then this final thing is the shell type thing that you want to use to actually log into the container. As you can see, this is not working well, and I actually don't know how to cancel out of this, which is really annoying. There's probably some smart person that knows how to do that. But let me do a cd into here and into front end and do the docker run. We'll call this front end. And now let me say I want to log in with the shell. sh means shell. Show me a shell. Don't give me the guff. So it seems like something is up, and normally you would get some sort of output. Let's try it through the visual environment here. Yeah, you see they're all trying to run and it's not working. Let me go in here in the front in the images and say run, and in the optional settings, let's just say run and see what happens. So it says running. Okay. And that one seems to be not shutting down. Okay, so that one looks good. So it must be my run command. I'm missing something, and that's okay. I'll pause the video and figure out what that is. But if you do it through the UI here, you can hit the CLI here. Boom. And we can now have a shell, /bin/sh for shell. And now we can actually do an ls and actually see what's on this machine, right? So this is a machine that is running with all of our stuff. Now, if you are a common Linux user, you're going to look at this root folder and be very unimpressed as to how it looks. So as you can see, we have a build directory here, which is not usually part of a Linux. We have Docker file in here and the package JSON. So usually all of this it should belong to a different folder, and we'll get there. I'll show you how to do that. But the point is we have a build directory, right? And when I do an ls on this is our React application right here. It has been built and it is in this container and ready to rock. These assets, if you will, this index.html, and in the static folder, if I go to static, you'll see there's a JS folder. And in the JS, this is our minified JavaScript code that we have created. This is our application. This is all of our front-end app is right here in these files. Okay, so we could literally take this stuff and deploy it to a web server and actually be able to interact with this content just like we would in our localhost environment. So this is all of the pieces that we have to play with, right? So if I go back to the root folder here, and if I say npm start, look what happens. Now I haven't tested this before, so hopefully this works. But as you can see, it's starting the development server. Okay. And I don't believe there's any ports that we specified, so I'm not sure what port it'll be running on. Does it tell me? Is it going to say... I assume it's probably like port 80. Unless the default is 3000. I actually don't know. So if I go in here and look at the images, does it give me any indication, or the container? Do I get any hints as to what ports? So node version, stats, logs... Not sure. So we'll just see. So I'll go to localhost 3000. Now hold on. I might be running the app. Hold on. Let me shut it down here. So that's a false positive. So if I refresh this, it's not loading. So now let me just try localhost. Yeah, and that's not loading either. Okay. So and that's because I didn't specify any ports in my container when I brought it up. So I'm actually not sure what port it has exposed, which it probably hasn't exposed any ports, which is probably why we can't get access to it. You need to actually expose ports. So let me stop this container that we had running there, which it should be able to just stop. Maybe I need to exit out of it. Let me exit out, and then there we go. Now it stopped. So it stopped. So let me hit pause and actually figure out the reason why my docker run command wasn't working, because we should figure that out. So I'll be right back. Okay, so, sorry, stuff just is on the screen there, but I figured it out. So the first problem was I was already running on port 3000, so that's probably one thing that was causing it to get hung up there. So because I was running it here in our normal, terminal window that we're used to in Visual Studio Code, it was using port 3000. So I obviously shut that down already, and then I was able to see errors. So that's why it got hung up. The second problem is that I'm trying to do this on a Windows machine, which all the other tries I've been doing, of course, has not been on a Linux machine or on a Windows machine. It's been on Linux boxes because I got the droplet set up first from DigitalOcean. Anyway, I figured out how to get it running. So it is Docker run. So it's Docker run. I think that -I is the interactive mode, and then sh is the shell that you want to use. But when I did this on a Windows machine, oh shoot, it got hung up again. The reason the issue I was running into, I guess I should have put /sh. I think that's probably also why it's getting hung up. So when I put /sh, as you can see in a previous run, it says the input device is not whatever TTY. So you should use winpty to run these commands. So that's what, on a Windows machine anyway, through git bash, that's the solution that I had to come up with. So let me go back to the assignment submission app, into the front end, and then I can do a Docker run with this. Let me do /sh, and then we can do the win. Shoot, what was it? Let's run it. Sorry, in interactive mode. IT. My bad. Here. So IT is the proper flag. Try prefixing the command with winpty. So winpty for what you call it is what you need to use. And then can I find module shell? Is it just sh? There. Okay. Phew. So you see, there's some trial and error here. Every other creator will just delete all the stuff that I've been struggling with. It's nice to see the struggle, right? So this is the proper command. So now, as you can see, I can ls, and I can actually see what's going on inside of this container instance right now. So that is a brief 36-minute overview of Docker, getting set up with a Docker file, some explanations as to what these images are that we're pulling from, and how to execute some commands. Now, obviously, we're in a situation where it's not running, it's not working properly. Although I did expose some ports, I'm interested to say, if I can say npm start here, if because we have the ports opened up, if it's actually going to work. So let's see what happens there. And then, of course, now this has taken longer to record than I originally anticipated. So I have a meeting coming up that I need to jump off to, but let me see if I go to localhost 3000. Yay, it's working. So this localhost 3000 that's running in is actually here inside of this server. I don't know how I can prove it. Can I go to login and then try to log in? And then there will be an error because I'm not running the backend code. There's no backend that's containerized, right? So it's trying to communicate with a backend right now, and there we go. See, ooh, look, proxy error. So that we got in this console window that I'm running the container inside of, that was the message inside of the container. Again, I can probably prove that by going into the container here, wherever it is running, and go to the CLI, and do it again, log in again, and go to this container, and we might see a message here. I don't know. Actually, no. So because we're running the dev server, this is where we're going to get the messages, not in here. But anyway, I promise this is running inside of the container. So that's pretty cool. We have now, you know, if I gave this Docker file to you, you could spin this up and do the same thing yourself, and it would just start running, and you'd be able to interact with it. So that's the point of Docker, to be able to simplify all the complexities that come from, you know, the it works on my machine problem. That's what it fixes, is it works on my machine. I don't know why it doesn't work on yours. So that's why Docker is so extremely powerful, and it makes our lives a lot easier going forward in the future with this stuff. So anyway, that is it for this. If you enjoyed this so far, the ramblings of one simple coder that doesn't have a lot of Docker experience, then stick around for the next one. You can go ahead and subscribe by clicking on the little circle above. Please do give this video a like if you've gotten a lot of value out of it. I would appreciate that. And yeah, until next time, I can't wait to see you. Take care of yourself. Happy learning, and bye for now.